Hello everyone, welcome to our channel. In today's video, we're going to talk about ultrasonic sensors like this. So what is an ultrasonic sensor and how can we use it? Let's dive it in. So before starting talking about ultrasonic sensors, you may want to know about another notion in physics, which is called sound waves. Sound waves are vibrations that travel through different mediums like air, water, and metals. Ultrasonic waves are those with a frequency higher than 20 kHz, making them inaudible to human ear. So essentially, ultrasonic waves are high-frequency sound waves that are not intended to be heard by human. But how does an ultrasonic sensor work? Well, it's pretty simple. The sensor has a transmitter that sends out a sound wave. If there is no obstacle in its path, the sound wave goes on forever. However, if there is an obstacle, the sound wave gets reflected back to the sensor. So to measure the distance between the sensor and the obstacle, we can use the time delay between the transmission T1 and the reception T2 of the sound wave. Let's call it delta T equal to T2 minus T1. Knowing that sound travels at a speed about 340 meters per second in the air, we can calculate the distance between the sensor and the obstacle. We have this formula D equal to C multiplied by delta T divided by 2. This principle is often referred to as time of flight. It's a method for measuring the distance between a sensor and an object based on the time difference between the emission of a signal and its return to the sensor after being reflected by an object. So why would you want to use an ultrasonic sensor? Well, these sensors have several advantages. They work reliably in lighting conditions, indoors or outdoors. Unlike optical technologies, they can detect clear objects, transparent materials, and the various surfaces. Ultrasonic sensors are also perfect for long-range detections for targets with different surface properties. They are not influenced by light, smoke, dust, color, or material, except for extreme soft surfaces like wool. You may not be able to detect this shape. But when should you consider using an ultrasonic sensor? They are best suited for non-contact detection such as presence detection, level measurement. They are great for measuring liquid levels, position and distance measurement such as collision avoidance in robotics, especially in applications where objects move slowly. Now let's take a closer look at one of the most popular ultrasonic sensors, the HC-SR04. This sensor consists of a transmitter, a receiver, and an electronic processing chip. It operates at a frequency of 40 kHz. It can measure distances ranging from 2 cm to 40 meters. Its ranging accuracy can reach up to 3 mm. It has 4 pins: VCC, trigger, echo, and ground. To send out an ultrasonic pulse, you need to set the trigger pin to a high state for 10 microseconds. This generates an 8-cycle ultrasonic burst that travels at the speed of the sound. The echo pin then goes high and waits for the wave to be reflected. If there is no reflection, the echo pin times out after 38 milliseconds, and it returns to a low state. But if it detects a reflection, it goes low earlier, and by measuring the time that the echo pin was high, we can calculate the distance from the sensor to the object. You might wonder why 8 cycles and why a 10 microsecond trigger pulse? Well, the receiver and transmitter need a few cycles to reach their peak amplitudes. Too many cycles aren't necessary, so this balance is ideal. To test out this sensor with Arduino, you will need an Arduino board. I'm using the Arduino Mega, but an Arduino Uno will work too. Some jumpers, an HC SR04 ultrasonic sensor, and a breadboard. Let's connect the HC SR04 to the Arduino. Connect VCC to 5V pin of the Arduino and the ground to ground pin of the Arduino. Connect trigger pin and the echo pin to any of the digital pins of Arduino. To make things easier, you can use the NeoPin library. If you are not familiar with it, you can easily download it from your Arduino IDE. Open your Arduino IDE on your computer. In the menu bar, select Tools, Manage Libraries, find NeoPin library by typing in the search. Click on Install to install the library. Now let's take a look at the code. You can copy this code into your Arduino IDE. The link of the code is in the description below. In this code, we've defined a few constants at the beginning of the code. Trigger pin, which is connected to pin 9, echo pin, which is connected to pin 8. Max distance sets the maximum measurable distance in centimeter. This sensor can measure up to 400 to 500 centimeter, but we've set it to 200 centimeter here. Then we'll create a new pin object to set up our ultrasonic sensor. In the setup function, we initialize the serial communication at a baud rate of 9600. This allows us to see the distance measurements in the Arduino IDE serial monitor. In the loop function, we have a small delay of 50 milliseconds between pins. This delay helps prevent excessive pinning of the sensor, so a smoother operation. The ultrasonic sensor can handle a minimum delay of 29 milliseconds. The Sona.pin centimeter function returns the object's distance in centimeter. If the measured distance is outside of the set range, for example, if it's greater than max distance, it will return 0. Then we print the distance to the serial monitor using serial.println function. And that's it. Now you are ready to test this code. Connect the Arduino to your computer. To test your code, you need to first click on the Verify button to check your code. Then click on the Upload button to upload your code on the Arduino board. Make sure you select the right Arduino board on Arduino IDE. You can watch the serial port display for the results. Make sure you select the right baud rate. In our case, it's 9600. Finally, it's time to test your setup. Let's see it in action. So this is a simple code which allows you to measure the distance between the ultrasonic sensor and an obstacle. You can use this information in various applications such as object detection, obstacle avoidance. Now you understand how does an ultrasonic sensor work and how to use it with Arduino. If you found this video exciting and helpful, Please don't forget to subscribe and like for more tech tutorials. Thank you for watching. See you next time.